Okay, so now I will simulate the impeller efficiency for the rotating impeller. So this is my profile, and, okay. So I have already obtained the result for the impeller efficiency at 0.03 zero .3 cubic meter per second, and the efficiency for that is 0.745176 or 74.52% efficiency with a torque of negative 1.47 Newton meter and mass flow rate of for the outlet of negative 0.36 kilogram per second. So now I will now show you on how I get these values. And when we compare the efficiency for zero point 0.3 cubic meter per second and zero point 0.5 cubic meter per second, the value is almost the same. It's just 74.54% for zero point 0.5 and 74.52% for 0.3 cubic meter per second. So there's only a minute difference for the efficiency. Next, uh, I have cloned this one and the impeller efficiency for 0.3 and then change the value of the flow rate to 0.5 cubic meter per second to obtain the result. So I will now show how did I set up this computational fluid dynamics for the impeller efficiency. So I have new project. Okay, now view user interface toolbars and click flow simulation, then wizard. Then you will name it as impeller efficiency and then I will use current. Next, SI. Okay, back muna natin. Back. Then next is SI. Okay. Next is we will have the internal analysis and exclude cavities without flow conditions. But we will need the rotation, so we will check it and we will set it to global rotating and z axis. No, z axis. Okay. At the angular velocity is 209.43951 radians per second. So that's it. So screenshot natin. Okay. So we will click next. So and then we will set the fluid to air. So the standard fluid. Screen. Next is adiabatic wall for the default wall thermal condition. So that means there is no heat coming out and in from the system. Then we will set it to standard atmospheric conditions at 101.325 Pascal and 23 degrees Celsius or 293.2 degrees Kelvin. Then click finish. So okay, for the boundary condition, so we will insert new boundary condition. Okay, first we will, okay, here, okay, we will set first pala the mesh, global mesh. We'll edit the definition. We'll set it to 4, and then set this one to 0.04 meter, 0.04 meter, and then close thin slot to 0.01 meter, 0.01 meters. So that's it. Next is, we'll check the global mesh. So next, we will need to specify the boundary condition for inlet volume flow 1 at 0.3. So, but we will use the 0.5. So we have already obtained the value for 0.3. Okay. So for 0.5, okay, we'll use the boundary condition. Uh, inlet volume, inlet volume flow, and we will set it to 0.5 cubic meters per second. Click absolute, and then global coordinate system. We will select inlet lead 1, inlet lead 1. Okay, for the inlet. So, okay. Next we will select, I okay, control event screenshot the parameters. Okay, screen. Next is for the environment pressure. Okay, outlet lead, environment pressure. Edit the, oh, dapat na nag-add boundary condition. Send boundary condition. Environment pressure. Yes. Okay. And then in outlet lead 1. Outlet lead. Okay. Outlet lead. And natin screenshot. Okay. Check. Then we will need to specify the wall. So real wall. So for this, we will need to So to cover boundary condition, real wall, okay. So, punta tayo ng boundary condition, insert boundary condition. Real wall. And then we will select the we will select cover component. Cover. And then select it as. We will list all components. Then filter the components. And then select outer faces. And keep. Remove outer faces. And keep outer fluid contacting. And select filter. Okay. Next, check na natin. So, ayan na yung nagiging result ng print screen. Next is real wall. Okay, so we will need to specify the project goals. So need is a mass flow rate and the mass flow rate for the inlet and the mass flow rate for the outlet lead. Okay, so pwede na natin silang ipagsabay. So mass flow rate. Okay, so insert surface goals, mass flow rate, check. Then for the we will the inlet and the outlet. Okay, so the inlet and the outlet lead. Then we need the surface goal also. Okay, so check na natin muna sila. Screenshot. And then select check. Okay, so we have no. Kunin muna natin si outlet. Delete muna natin. For the outlet. Next is mag-insert tayo ng another mass flow rate. We'll rename it to inlet. Insert glow. Oh no, not global goals. Insert surface goals. Mass flow rate, but outlet lead. Okay. Then rename it to outlet. Outlet. Next, for the surface goal, torque. So we will insert surface goals. Need to select torque, torque at Z, and select all impeller faces. Okay, so we need to select the impeller. Delete na lang to. And impeller. And select faces. And then ilalagay natin remove outer faces and keep outer. Remove outer and keep outer. Okay. And then check filter. Naghang pa. Lalagyan. And then check surface goals. Next is tapos na tayo sa torque. And then we will need to make a for formula. So we'll select equation goals. This is for the pressure drop. And then static average pressure inlet. Did I make this one? Oh no, hindi ko pa nagawa pala. Wait, where is SGB static? Surface goal, inlet lead. Average static pressure. Okay, so walang pa tayo. Ang goals, surface goals. Static pressure average. And then inlet lead. Select. Okay. Screen natin. Okay. Next. Insert. We'll need back average static pressure. Inner measuring. Surface goal. Back average static. And then ayan. Measuring inner face. Check. Check natin. And then next for the back average torque. Okay, so sunod is the pressure drop. Okay, finally, if you will make an equation goal. Pressure drop. And then SG average static pressure minus the back average stator impellers outlet. Okay, and then pressure and stress. Check. Okay, check na then. Impellers. Okay, next is, yeah, equation goal. For the equation goal, next is efficiency. Efficiency. So no unit, we will need the pressure drop minus back average, times pala, times the average for the back volume flow 1, and then for the flow rate 5, 5, so 209.44 over 209.44 all over torque on impeller, torque, torque on impeller, and then, okay, check. So check. So ayan, so these are the results. Okay, and then you know that there is another thing. We go to the component control. Okay, so for this one we need to component control. I need to go to the feature design manager 3, measure, back to flow simulation, project. I know this one. The measure component control. And component control. Then we will disable this one, the measure component. So we will disable that and check. Okay. And then next. Okay, so after that for this we will run the program or the calculation, I mean, and then we will eventually be getting these values for as a result. Okay, so that's it. That's how I set up my CFD for the rotating impeller. Thank you.